There we go. I kill that. You don't need to see me as well, because it's just me. So, there's a bunch of pieces we're going to cover today. The first one I'm going to get into is a little bit about programming. As far as you guys go, some of you have had a little bit of experience before, and some of you have had a little bit less experience. I would say pretty consistently, by about the second week of term 2, we've usually surpassed everything that everybody's done before, especially those that have done computer science degrees. So if you don't feel super confident that you've done lots of programming before or a significant amount of it, don't worry about it. We are absolutely going to get everybody caught up to the same place. Okay. In order to do that, we're going to tackle a bunch of different programming tasks and a bunch of different programming languages, mostly because you'll see the similarities between them. Especially when you look at C# and C++, a lot of the material you'll do is very, very similar. And the idea there is to be able to highlight the similarities so that it's really just about, where do the curly brackets and the semicolons go. The other thing you probably should have noticed already, and we're going to do the same thing with the web stuff, is that there are a lot of different components in modern software, from the language that you're using to the way that the programs are built with the language to the libraries that those languages use, all the way up until frameworks. And the goal ultimately is to get you using frameworks. And we will explain the difference between a library and a framework. But you should understand that Unity and Unreal are frameworks, and that .NET and the web use libraries. And eventually we'll get to crossing the two over. Which always leads me to my first question is, so if we're doing game development all the time, why the heck do we do web-based development? Anybody got a good idea why we do the web? Yeah, there is one aspect of that where it's a gateway drug. Right. Other aspects? I came here to do game programming. What the heck is this web stuff? It's weird and it's different. Well, I'll enlighten you with a big part of it, is that games these days are delivered as services. Those services include operations where the game is being run live, multiple players, whether they're playing single player games and storing their information or whether they're connecting to each other live. And someone has to manage those services. As an example, has anyone ever played the mobile game Contest of Champions by Kabam? No. Do you know it exists even? Well, you can look it up on the App Store, whatever. It's one of the bigger mobile games out there. Kabam has 100 people working on that game. 25 of them build the client for Android and iOS in Unity. What do the other 75 people working on that game do? The back end. And what do they do the back end in? JavaScript. The cloud. So we do HTML programming for two reasons. One, we're not going to rely on frameworks, so you're going to see how things fit together. You're going to learn programming concepts where you don't have a huge support network of libraries and frameworks to make life easy for you, but it is also easier to understand what's going on. But specifically because we want to get to the cloud. We want to be able to store information in the cloud. We want to be able to work with cloud data. And once we start working with that cloud data, we are going to have to interact with it. And the most natural way to interact with it is to build web applications that you can run in a browser so that you can interact with the cloud data. In order to learn how to do all of that, we're going to build some web applications. And that gets us into that whole, what is programming? And I kind of alluded to this the other day, is that programming has less to do with languages and more to do with just problem solving. And the languages we use, the editors we use, those are all just tools. You can probably get almost any tool to help you with any other programming problem. And in fact, we'll probably put a couple new tools in there today. The tools that you use for C# and C++ are very large, challenging to install, can't be installed unless you're the administrator locally, and 99% of the time, you're using them as a text editor. So you get to wait for the startup and you get to see all the resources on your machine go away because you want to edit text. But Notepad sucks. So we're going to get into how do we get that middle ground, which probably means another tool. We're also going to talk a little bit about how the web differs from some of the other programming environments you have. Specifically, the web is interpreted as opposed to compiled. And those are two different methodologies to get to the same thing. When you're building a compiled program, just like we were talking in the operating system class, you have to write something in a language, have one program turn it into another language, have one program turn it into machine code. It does the whole program all at once. It compiles it into machine code. When we're working on the web, we don't do that. We take one line at a time and we interpret it and then we do something. Now, the upside is you get instant results. Yay! The downside is there's no compiler to tell you when something went wrong. There's no magic errors going to pop up that says, hey, you should have used an integer here. So instead of that, we have the ability to be a little bit more flexible in the way we interpret what can run and what can't. So we're going to have to introduce some new techniques with you guys on how to develop and debug these things. For the most part, I find it's a lot faster. We've done lots of stuff in a lot of different tools and languages I have over the years, and for me, developing for the web is one of the most rewarding because I'm not waiting. What I see in the browser is what I wrote 2 seconds ago. And if it doesn't work very quickly. I'm not waiting 3 minutes for Unity to compile everything and then start everything up just to throw a simple syntax error that I have to go check and fix and then compile again, all of which is because I wanted to use some number and I used the wrong size of a number in the wrong place. And now I just lost 6 minutes of my day that I will never, ever, ever get back again. So developing for the web for me is kind of much more liberating. The downside is, and I think even David would attest to this, there's a certain amount of programmer discipline that you need to be able to make things work. You're going to have to kind of look at stuff yourself and figure it out. Why doesn't this work? There isn't going to be some magic set of tools that's going to point you at this line number doesn't work properly. Now, we will give you some things to help you, but there's going to be a little bit more emphasis on you figuring things out. Now, what is programming really? It's really just creating a repeatable set of steps to solve some problem. As I said the other day, the biggest problem we're solving in games is trying to get an emotional reaction out of a player. We're going to do some sort of simulation. We're going to set it up. We're going to get it running in that we're going to update it very frequently. And then we're going to draw those updates on the screen and we're going to wait for user input. And one of the things by developing web apps and web games is going to help us is going to help us understand exactly what's going on under the hood. Because a lot of the stuff we're going to do on the web side of things in the first 4 months are things that Unity and Unreal just does for you. So when you dive into those game engines, those frameworks, and someone says, hey, where does execution start? You're not going to throw your hands in the air and go, I have no idea. I don't know what starts first or when. You're going to be like, well, the framework probably does this for me, because you'll have had to write it on the website. Now that said, building forms all day in the web is not much fun either. So while we will do some of that, we're going to build some games to begin with. Just because it's more fun and more interesting to build games. So in this course, we're going to build a game as a term project. We got a couple stepping stone assignments along the way, but we're going to build a full-on front-end to back-end game in this first 8 weeks. And then in next term, we're going to turn around and we're going to do it again. Only we're going to build a couple tools for the game first. And then we're going to build the game probably in teams. So we can get an idea of how we build things. First, remember these things, okay? Just because something's working doesn't mean it's good. And just because it's good doesn't mean it works. Right? Now, the ultimate goal is that it's good and it's working. But does it make sense what I'm saying here? Right? You can build things in a really, really well-built way, and it doesn't work perfectly. There's some bug or error in it. Okay? As you go through all of your time at VFS, submit things, even if they're not working. Okay? And there's a really good, straightforward reason for why. Remember the first day I was talking about how, most of the time when we have to give zeros out for things, it's because people don't submit things. I can't mark what doesn't exist. If it exists, I can give you something for it. If it exists and is my template given back to me, I can still give you 5 marks for copying it back into Moodle correctly. And that's 5 more marks than a 0. Now, none of you are going to be like that because you're all programming students. And that means that you're going to be held to a little bit higher standard than the game design students. You're going to do everything because there's no point in coming here to try and learn how to program if you're not going to do the work and learn how to program. Right. Arsene, do you have that whole room to yourself? Yeah. Is it cold in there? It's good. We may end up doing that. With all the COVID stuff, we've got a small group of people in a fairly large classroom, which means we can space ourselves out a lot, which means we may have a chat collectively about how far we go with masks and stuff inside the classroom. Just, think about it. Think about how comfortable you feel with that. Usually I don't, because I can stay away at the front. And it's easier to hear me. Just, kind of clued in for a moment. I recognized the classroom. I'm like, wait a minute. He's all alone there. We will get back there, I guess. Okay, so the point I was trying to make here was, as you do work, if you have something, submit it, even if you think it's going to be late, and update it. Okay? The don't ask, don't tell aspect of a lot of the instructors is pretty common. The school's policy is if something's late, even a minute, it gets a 0. The game design and programming instructor's policy is, I would rather you give it to me and I will grade it. Okay? I don't care how late it is. As long as it's in the term. Now, I may take some marks off for it being late. But wouldn't you rather have me take 10 or 15 marks off for it being late than get a 0 on it? So, balance your time Make sure that as you do the assignments, do them the right way and then make them work. Don't worry about making them work first, right? And I say that because you're all going to fall into this, especially with web programming. You're going to go look out on the internet. You're going to look out on the internet for help on how to do things. And I'm going to warn you right now that what you find on the internet is 99% bad. More so than anything else, when we deal with web programming, think about how many browsers are in the world. So what programming environment has more programmers than anyone else? Right? Web development, digital design. And how many of those programmers are trained? Very, very few. And even fewer of them are trained in web programming. Right? So it's likely that when you go to find something on the internet, because you didn't really get how it worked, what you find on the internet is some 13-year-old who once copied a 12-year-old who figured out that something made it work, and they don't know why, but they cut and paste some piece of code in. And you're putting something in from 2003 that just happens to still work, because most of the stuff in the web we don't ever deprecate because we don't want to break the whole internet. Does that mean it's good? No. So there's certain things I'm going to steer you away from. Right? You will know, I will tell you. David even knows. David knows my key hot points when it comes to certain JavaScript things that are just bad. But you see them all over the place. In fact, you'll see them everywhere. So I'll point out what they are when we get there. Is that guy coming? There it is. I always like to show this little chart. You know, it's kind of indicative of the way development works and the way you should expect development to work. That dotted line that is art in the middle there, that is the way all the stuff that Jeff teaches you progresses. The more you do, the better you get. It's really kind of, this way. The more you do, the better you get. Right? Programming doesn't work that way. Programming is quite often something that is much, much more painful. I have no idea how this works. I don't know what the hell I'm doing. I'm an idiot. And then right about here, something clicks and you're like, oh, I get it. And you work like mad and a whole bunch of stuff works and you think you're a genius. I totally understand this. It's going to be great. And then you get to the next thing you want to do, which is really hard. And you're like, oh, I don't know how this works anymore. I'm such an idiot. Oh my God, how come I can't figure this out? You'll struggle with it for a couple days. And then all of a sudden you'll click or you'll ask somebody and you'll figure it out and you'll progress more and you'll be like, oh yeah, I totally get that. That's great. That's awesome. That little stepping cycle never ends. It's the same cycle I go through. I just start farther along the track. But inevitably, I think I know exactly how this stuff works. And then I'll go try and do something that to you might seem super complicated, but to me just totally makes sense, and it doesn't work. And I'll sit there for a couple days trying to figure it out, going, I'm an idiot. Why don't I figure out how this works? I teach this stuff. How come I can't figure out how this works? And then I'll discover something new, or I'll try a new technique, or I'll try a new approach to it. And all of a sudden things start to work again. I'm like, oh yeah, I got it. I know what I'm doing. Right? That never ends throughout your whole career. So the warning here is just be prepared for it. You're going to go through these great periods of elation where you totally make things work and you understand what's going on, and it's fabulous. And then you're going to run into a roadblock, and that roadblock is going to make you feel like you're this big and you're just an idiot. Already. Just keep working through it, okay? Yeah. Drawing wasn't coming through. Okay. I know what I'm doing. I'll switch something out at a break. I'm trying a new tool. I have a new drawing tablet I can try. So, thank you. All right. So, 90% of what we're doing when we're going to program stuff is we're going to manage data. So, that's why we do that data structures and algorithm course. Okay. Whenever we store stuff, that data we store is something we're going to manipulate. And eventually these things will get really complicated, but for the most part, we're going to store some information somewhere and we're going to present some feedback to the user based on that information. And then the user's going to do something that's going to change that information. We're going to have to show it back to them again. So there's going to be a lot of stuff where we're going to focus on how do we store the information? What is the most efficient way to do it? Right? And to do that, we're going to start by looking at, understanding our problem. And this is kind of an engineering approach to things, right? Which is why if you've picked up those backpacks from the school, and if you haven't, you should, there's a kit there for you, and it's full of a bunch of low-tech stuff, like a backpack, and I think there's an umbrella still in it, and there's a notebook in it. Right. So the reason it's a notebook and not a notepad is because most tech companies run with engineers using engineering notebooks. And those are those little black covered books. They're solid bound. The pages don't come out. You're supposed to write in pen, in ink. Okay. And there's a very specific reason that engineers do it that way. Software engineers too. And the reason is that in most companies and countries, there are specific tax credits that can be gained by proving that you're doing research and development work. Not just research, also development. And the way you prove you're doing development work is you collect up all the engineers' notebooks and you summarize them. Every page has a date on it. And then just your scribbles. Just do your scribbles in the notebook. Because that way, when you and I come up with the same idea, you flip to a page in the notebook and you show the scribble where you came up with the idea, and it's got a date that's earlier than when I came up with the idea. You own the idea. That's how you prove that you've done the work, right? So we ask people to work in those engineering notebooks, even though it's not comfortable to begin with. You'll maintain a library of them over time. Some companies ask to retain them when you leave. Some companies just want to see the notebook and then hand it back to you, and they'll write up their report to get their tax credits in whatever country they're in. In Canada, it's worth 20% of your project budget. So if you have $1 million budget, that's $200,000 you get given by the government because you can prove you're doing research and development. And you prove that by putting all the notebooks together. You write a summary, and if they question it, they come back and say, well, we don't believe you did this. You pull out the notebook and says, well, here it is. On this day, we tried this stuff. Okay, yes, here's your $200,000 check. So we encourage you to get into that habit early, right? We're also going to use some tools probably earlier than the game design students do. We're going to get into using the source control tools. Most of you guys probably have seen them before. We're going to set them up today with you. We're going to, all of our schools since we've been online have been using Git as a source control tool. And I will get into it. Is there anybody who hasn't used a source control tool before? Okay. Has anybody used anything other than Git? What was it? Bitbucket. Okay, Bitbucket is Git as well. Okay, so we'll talk about Git, GitHub, and Bitbucket and what are the differences between them. Right. All right. When we're working with people, we're often not working alone as well. So we're going to work with designers, and I want you to encourage yourselves to work with designers. You have different responsibilities. And anytime we see team projects that are led by programmers, unless they're really seasoned and experienced, it's usually a disaster. Right, David? There are some core responsibilities, and yes, there are exceptions to the rule, but typically designers are focused on workflow, look and feel. How does the user interact with this application? In a game design case, that's what are the rules of the game? How do I win? Right? The programmers are responsible for realizing that vision. How do I make it happen? What's interactive? How do I design and build this thing in a way that's extensible and maintainable? Because we're going to get into building code, and that code is not going to be right the first time. We're going to have to change it. And who's going to have to change the code you write? You are. So, we'll alleviate the first question all the way. Hugo told you to write comments in your code. Rohit told you to write comments in your code. Did they tell you what to write? And how? Well, I typically drop the what and the how because I know how to read code. So if you can write the code, I can probably read it. But the why is the critical part. Why did you do this? Why did you do this way? Write the comments to yourself, your future self. Because 6 months from now, you're the one who's going to have to maintain the thing that you built. Right? When it breaks, someone's going to go and look in the source control system and say, hey, you know what? It was Clover who wrote this, and we need it fixed, so hand it back, and she can just fix it. And you'll open up your own piece of code, and you'll be like, what the hell did I do here? And why did I do it this way? Who was the stupid person who wrote it this way? Oh, damn, it was me. Right? So if you have a few comments in there telling you why you did things, what your thought process was, written to your future self, you're going to help yourself tremendously. Now, for that reason, because we typically have to maintain the things we do, I'm going to focus on showing you ways to do things that are easy to maintain. Okay? And that means we're going to try and avoid being super clever because, you know, there's this comment that's out there, right? Kernighan's law. Don't be too clever. Right. So let me flip this around. Enough with the thing. Let's get ourselves set up and start to do some stuff. All right. Too many things going on. So, building for the web, we've got a couple environments we have to work with. The web is inherently a client-server environment. The client is your browser. The server is a web server. In order to build applications locally, we need a web server locally. And I don't know about you, but I've installed and configured a bunch of local web servers, and it's not fun. And it has nothing to do with programming for the web. And fortunately, a number of other people thought the same way. And about 10, 15 years ago, they kind of peeled out the core of JavaScript into a separate environment and allowed that environment to run as a standalone. Does anyone have an idea what that environment's called? Nope. Nope. Node.js. Yeah. So you can think of the JavaScript engine as a self-contained module. Every browser includes it. And the Node.js environment takes that JavaScript environment and wraps it up in a command line so that we can use it as a standalone thing. Now, Node.js by itself is just a JavaScript interpreter. We need to have Node.js in order to do anything else. What we will do is we will install Node packages that are downloaded from the internet. And those Node packages provide functionality. Effectively, Node lets us write JavaScript locally and run JavaScript programs because it's an interpreter. So some people have written web servers as Node programs. So whenever we're building our web applications, we're going to need to have a web server running in the background. Now, fortunately, there's some pre-built web servers that make life really, really easy. So we're going to install Node, and then we're going to install one of these web servers so that we don't have to worry about the server side. We can just write our JavaScript HTML code to run on the client side. That means we're going to need a few things. One, we're going to need Node.js locally. So at the school, we have Node.js pre-installed. Yay! Here, or at home, you're going to need Node.js installed. And let me just pop up a terminal. Look at this. Let's do this guy. Yay. So, the Windows command prompt, you all familiar with it? All right. CD tells you what directory you're in. I've got a very fancy prompt there. Don't let it distract you too much. If you just go to the start menu and type CMD. Should really turn the task manager on the screen I'm sharing. Nobody runs anything other than Windows. Come on. Don't run other than Windows. Game devs run Windows. Let's just put that out there right away. Be on a wire. Make sure you have lots of memory in your computer. More screens is always better. Every game developer out there runs on Windows and Windows alone. There are no Macs. There are no Linux boxes. Thou shalt run Windows.
I got 3 of those 4 things. Yeah, I'm missing the wire.
You're missing the wire?
Missing the wire.
The wire won't hurt you with the web. You can do everything wireless on the web.
Yeah.
You can do it.
Yeah.
And probably in term 1, you won't even notice it.
Yeah.
Right? But I guarantee you, I can get you to load a package into Unreal that will drive your internet into the ground.
Yeah.
And you'll be half an hour behind everybody while you wait for things to load.
There's no portable adapter. I don't know if it can handle it.
Yeah. Let me turn this on.
Now, are we installing Node.js right now?
Yeah, if you don't have it.
Which version? There's 2 versions.
That's what I was just going to go check. It's usually the LTS version because we don't need anything special.
The LTS.
Yeah. And if you want to check if you had it, just type Node. So 14.17. Sure. What is the current LTS?
13.1. It's the most recommended features.
Yeah, grab that one. Sure, I'll do it too.
14 right now, is that 5? Just at the 14?
Yeah. it honestly won't make a big difference.
Yeah.
For what we're doing. Right. .exit gets you out.
Got it now.
Okay. The second thing to install, I have listed here, is Visual Studio Code. Oops. So, I'm sure the guys had you install Visual Studio Community the other night.
Yeah.
And Visual Studio Community is like this 800-pound gorilla full of visual development environment and 27 language packs that you have to install. And what do you mostly need is an editor. Right. So you can use that to do web development. You just have to learn to start it ahead of time and learn that it's fairly heavyweight. I don't use it. I don't even use it for C# or C++ development.
No, we'll be using Visual Studio Code. I think
Right.
I'm on it.
And I'm going to try and convince you over the course of the next couple months that Visual Studio Code is a fast, lightweight editor that can do everything that the other environment can do and can do it for free. And you can even install it and configure it your way on the school computers without administrator. So again, it's just the LTS version, the latest version. If you install it yourself on your home computer, or Arseny installs it on the local computer at VFS, it will auto-update itself every month. If you use the pre-installed one at VFS, it will be out of date today.
I don't even think we have Visual Studio Code.
Yeah, it is.
Do we install the user installer, system installer, or the .setup?
The user install. That'll install it in your user folder. And to be clear, yeah, when you bring up the File Explorer, if you see these item checkboxes on things, you're using Windows in rookie mode. Nothing says to a pro developer that you don't know what you're doing faster than you still use the default settings in the File Explorer. So turn the stupid item checkboxes off. You don't need them. Most people either use the details view because you want to see the date modified, or they'll use a tile view.
That was a quick install.
It should be. It should be.
So do you want us to open that and use it?
Yeah, I think that's great. Because there's a really cool feature, and it works cross editor. So whether it's Visual Studio Code or Visual Studio Community, they have a live share system. So rather than you looking at the 720 or 1080p screen that you see in Discord to try and see what code we're writing, in Term 2, Quinn does this as well, but I will share, using the live share, my Visual Studio Code when we get there. Okay? And when we do it, and we're going to do it today, I will send you a link. It'll be in your Discord channel. You'll click on the link, and it will pop up Visual Studio Code with a live connection to my Visual Studio Code, and you can see what I type as I type it. So again, the second screen is really helpful if you have a second display. Particularly for the web, you'll find you're going to need more screen real estate. In this term, it won't be so bad because you're going to have your editor and your browser and a debugger, 3 separate windows open. If you're used to just maximizing things on the screen, like I have showing you right here, right now, you're going to run into some pain. Instead, you're probably going to want to line up windows. Okay, and that's what you see on the bottom is what we're kind of broadcasting. What you see on the top is kind of what my screens look like. All right, so we got Node We got Visual Studio Code. We got a pen and paper. You're always going to need something to write on beside you. Okay? You're going to run into situations where you're going to need to make some notes. And they're just going to be scribbles, but that's what that engineering notebook's for. So you don't have papers all over your desk. Now, later today, we're going to set up a repository for you in GitHub. Okay, I'll send you an invite. When you do all of this stuff through the school, I highly, highly, highly recommend, again, use your school email address. Right? Particularly when it comes to programmers and code. Whether or not they're supposed to do it, whenever you apply for a job, people are going to go look your name up and they're going to go try and find work you've done before to see what your code looks like. If you do everything under your own personal GitHub account, some of it's going to be public. And you may not want those things shared with the world. So what I recommend you do is for your whole year here is you use your VFS email to get a VFS Google account and a VFS GitHub account, which I will send you the invites for our environment. And it's all private. And then you can go ahead and make as many mistakes as you want in that private space. And then in your public version, your own personal version, you can create copies of things that are highly polished. And then anyone finding those things on the internet will go, wow, this person writes really nice, clean code. First time out, too. Like, beautiful. The reality is you've got this VFS one in the background, which is full of all sorts of crap you did along the way. So it's an unfortunate reality of today's developers. It's not like you send out a resume and that's the only information they have on you till they have an interview with you. You send out a resume and they start digging through everything that has your name on it. And have you ever done a Google search on yourself?
Yeah, no. Actually, yes, I have. Nothing came up.
You should definitely go do a Google search on yourself. You can set up alerts too.
Just Instagram, LinkedIn, Facebook. I think it just get billions of results. Yeah. And then I just get some sort of TV direct. Oh, I got the game and game jam.
Just to keep things honest, for my children, I set up Google Alerts. Google alerts me anytime someone writes anything online about any of my children.
I searched my name and I found the dog's picture.
Mm-hmm.
Yeah, I got nothing.
All right. So you want to keep it that way, right?
Got a bunch of old guys.
Yeah, I show up in all sorts of places. The only place that I get annoyed about is there are certain sites that people write stuff that you can't edit yourself. Right? Does anyone still have a Facebook account?
Never made one. Actually, I have one, but it's only for my VR headset.
Right. So just make sure after you've created it, you take your date of birth and middle names and addresses and all that stuff out of it. You can go and delete the stuff after you've created the account.
Apparently, if you do that with Oculus, they ban your account.
For deleting the data? And they wonder why headsets aren't taking off.
Yeah. Well, Facebook is useful for it. For birthdays. Yeah.
All right. So here's what I recommend you do. On your computer, you're going to have a bunch of folders. All of your information, and I'm just going to bring mine up. All of your information resides, if we look at your computer, I have a couple hard drives here. On your C drive, there's a users folder. And that users folder is where all the user accounts for this computer are. This is the same at the school as it is here at home. Okay. The public folder anybody can write into. The users folder can only be seen by the current user that's logged in. Okay. For our work, I've got everything turned on. Let me just kill all the hidden stuff. There we go. So what I recommend you do, because there's lots of crap in there, is create a VFS folder for your VFS work. Okay. And that's not a big stretch. Now, underneath the VFS work, we're going to have one specific folder that I'm interested in. Create a folder called repos for repositories. Okay. And this is kind of a common way people do stuff.
Sorry, how'd you get that?
On your C drive,
Yeah,
users, your username,
yeah,
and then you're in your home folder at that point.
yeah.
So then create a folder called VFS. New folder. And in there, eventually you'll create other stuff as well, but in there, create a repos folder. Now, the reason we do this is that everything under the repos folder will have a source repository somewhere. Bitbucket, GitHub, Perforce, CBS, whatever. It's stuff that's in source control. Source control are programs because programmers are lazy. Right? Typically, people get into programming because you want the computer to do the work, not you. So one of the things that became very apparent very early is when we're writing software, we typically have lots of files, and those files have lots of versions on them. So source control or version control is about how do you manage every version of every file you've ever made. And what do you do when your project has 4,652 files in it and you need to keep 300 versions of each file? Do you continue to make backup copies of the whole folder? Rookie? Or do you use a source control system? Well, you use a source control system. And that's a tool that programmers wrote to help manage all those versions. One of the most popular tools right now is Git. Git is a command line tool. You can do everything on the command line. David's an expert. Okay. Those Git command lines help you keep versions locally. And I'll get into this graphically a little bit later today. The versions that we keep on our local computer, we can also share with a remote computer. There are a couple services that offer a certain amount of free space on a remote computer. And they offer an infinitely larger amount of space if you pay for it. Two of those services are Atlassian's Bitbucket and Microsoft's GitHub, as well as GitLabs. Okay. Vancouver Film School's Game Design and Programming for Games department has a commercial GitHub repository. So it's private and it's huge. And that's why we want you to use your VFS email, because I'll use your VFS email to send you an invite today. Inside there, we're going to create a copy of stuff that's on your local computer. The reason I create the repos folder in your file manager here is because I want to know very quickly at a glance all the stuff on my computer that's also stored in a source repository. I don't want to have it mixed in with all of my separate assets or separate projects that aren't saved somewhere else. So we create this repos folder so we know where our stuff ends up. How you organize it under here is really up to you. What I recommend you do is you create a www folder for web stuff. And only www versus sites, which is what Apple uses, because www is only 3 characters and sites is 6, and typing 3 less characters is faster and less work, and I'm lazy.
Uppercase or lowercase or whatever?
Doesn't matter. The Windows file system is case insensitive. So we typically do everything in lowercase because otherwise we're yelling. The other thing is that because we're using the command line, and the command line is not, and we'll get into this more, but because the command line typically separates parameters with spaces, never, ever, ever put a space in a file name or a folder name. That's just asking for trouble. Right? I'll get you to do some stuff with that next week that'll make life interesting. So I can get rid of that. Once I'm in that repos folder, I want to make sure that I can play around with things. So we're going to follow these instructions. We're going to make a hello directory, and we're going to go into that hello directory. And I'm going to do that from the command prompt. I'm going to type from the start menu, I'm going to type CMD. That's going to bring up one of these guys. Eek. Come on down there. And when you start, you'll notice what folder I'm in. I'm in my home folder. That's user Scott. If I do a dir, that's a directory listing. If I want help, type help.
I did the VNS thing that said syntax error on the fire.
When you type VFS on the command prompt?
Yeah.
Yeah. Just like that.
Oh. Does it have to be lowercase?
Doesn't care. I'm going to go into my VFS folder, repos.
So not working, it says unexpected identifier as VFS.
It's yeah, the way you've typed it, it thinks VFS is a command.
Okay, so you did type in the big directory, PGR.
Just like that. Yeah. 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 Just share your screen. Oh, you're still in the node environment. You're not on the command prompt. So type .exit first. Now try it. Just do VFS. Just one at a time. Andre, just make dir VFS. Already exists. So change directory into there. CD space VFS. Now make dir repos. So change directory into there, Andre. Right. Make dir www. Yeah. So CD into www. And make dir hello. And go look at it in your file explorer. Got it? Cool. No, you just leave it there.
I got it. Now I got it. Sorry about that. No, sorry. Present it. Okay. You already made your VFS folder. Just you go into that folder where you can change directory or cp. And then VFS. Yeah. Oh, got it. Now it's CD, repos. Oh, I remember you already made the repos. Oh, I made that. Okay, I got it. Thanks, baby.
Can you see that, Nick?
Yeah, I can see it now.
So I'm in the users Scott VFS repos demo folder. Users Scott VFS repos demo. It doesn't matter which view I have on it. They're views into my hard drive. The bio folder and the bio folder. That www folder, that's the same folder. You're muted, Arseny. All right. So now that we have our folders created, we're going to try something. The next line down there, npm node package manager. When you installed Node, the Node package manager gets installed by default. And hopefully it updated your environment. And we'll get into that environment in a sec, if we have to. That npm command, you just type it on its own to see if it runs.
Yeah, it ran.
And it gives you all the kind of options if you don't give it any. So, CLS clears the screen. npm install live server. You notice everything's separated with spaces. Now, the reason I picked the live server, this is just a program somebody wrote that's a Node JavaScript program, but it simulates a web server. And later on, we're going to use it to help you build and debug client-side web applications. We're going to fake out the server on your local machine, so you don't need to have an internet connection to test out web stuff. Right? So try and install that live server right now. Yep. And you have to put the -G in there. The -G says install it globally. Otherwise, you'll have to install it every time you want to use it. And mine should. All good. Now, see all those warnings? Ignore them. Right? You can read through what they are. It says warn, deprecated, Urix 0.1.0. So there's a library that this live server uses that's been outdated. That's what deprecated means. It no longer is the most current one. So you can update these things manually. It even gives you the command to do it. npm audit fix. Okay. Is there anyone that wasn't able to run npm? Well, good. Well, open it up again. You can have lots of these things. And you will. I can do this.
starting to feel like I need numbers. I just had one and we could be on the 3 should be the minimum. The 3 should be the minimum?
2. 2. You can live with 2.
Yeah,
Okay.
The
trick is the moment you start doing this, you're screwed. The reason we have windows is so that you can make windows. It doesn't need to be that wide.
Yeah, right now I have it on half minimum.
Yeah. So if you have 2 screens, 2 physical screens, that's awesome. That's optimal because you'll have left, right on both screens. Right? One of the screens will be your work, the editor and the browser. The other screen will be what you're watching from me and my live share.
Yeah, I just have my second runner. It's all you.
So you'll make me smaller. You don't need me that big. It's not that important. You'll make me half a screen, and then my live share in VS Code will be the other half. No. Yeah, you are. You can turn it off. Are you running through the browser, Clover? Yeah. Okay, so there's a trick with the browser. There's a little dance you have to do. With the browser version of Discord, you have to turn off your video first. You have to stop watching my stream, and then you can stream yours, and then you can turn your video back on and watch. Go back and watch me.
You think they figured that out by now?
It's a very specific bug.
You know what Discord's coded in?
Yep, I do.
Can you see my screen?
No. Yeah. So stop sharing, stop watching me, then turn your video off. Now share your screen. There you go, Clover. Okay, now you can turn your video on, your camera back on, Clover. There. Isn't that weird? Yeah.
What is the issue you were having? What's the thing? Right? You were saying that everything disappeared. What's the issue? Yeah. But I had all things and then I suddenly closed the tab and then
Well, that's okay. Just go back there. Change directory. CD. Space. Oh. CD space. And then just type the name of the folder. No funky characters, no nothing, just BFS. Hit return. There you go. Type dir. What folders are there? That's doing a directory listing. Hit return.
just press enter so you can see what folders you have in there. I don't know actually what am I doing. So what you're doing with dir, you're listing all the items in your directory. So basically you're now looking at a folder. You're in a folder in users in CFS. And you click when you put dir, it's going to show you all the folders inside. Just click enter. Showing you you have one folder called repos. Then CD stands for change directory. So if you want to go into that directory, press CD and then go folder. So I was showing earlier, if you open just your file explorer, you can go to that folder just the same. You can go user and DFS resource. It's all different ways of looking at things.
See if you can make a folder called hello there. Type dir first. Let's see what you got. Okay. Try typing makedir, mkdir, space hello. Okay. Type dir. Okay, now bring up a file explorer, Windows Explorer. There's one right there. So drag it over so we can see it.
Oh, okay. There we go.
Okay. Is that the same?
Yeah.
Those are two different views into the same thing. That's your hard drive. And if you click in the address bar of the file explorer, up here, just go to where mine is. If you click in the address bar, it'll highlight it. You can actually copy it from there and go paste it into a terminal if you want. Gotta copy it.
Oh, that's easier. You want that even easier. Clover, go back into your, close your command prompt. Open up your folder. Go into the address bar. Now just write CMD. Press enter. There you go. It opens it straight to your folder. Thanks for everything.
All right. Let's take a 10-minute break. When we come back, we'll start diving into like actual programming stuff now that we have a place to put it. Okay?
Okay.
All right. Let's see if we can start to work on some stuff. All right. So we have a folder to put things in now. That www folder is where we're going to build the majority of our applications. And because the web applications typically have lots of files, but they're fairly small, I would recommend we'll build one repository and have multiple folders underneath that repository. It's easier for you. So the next thing to look at is for us to take a look at, what exactly does an HTML document look like? And we have the pieces in place to fake out a server. We can run it as if we're going to a website. We can go test things out locally, and I'll show you how we do that as we build them. So the first thing we need to know is, what the hell do we build here? So we start with an HTML document, and there's a bunch of versions of things that you'll see thrown around. HTML5 is about 15 years old now, and it was the answer to the fact that the web technology started to fall behind what modern hardware could do, and people were clamoring for a way that within the browser we could access the graphics context. In addition to that, the HTML5 specification also added a whole bunch of new capabilities and further separated out three main parts of the web. Those three main parts of the web are some sort of markup or framework. This is the structure that we're going to hang everything off of. And it's a lot like the framing in a house. We're going to need some sort of structure to start with. That's the part we're going to start from. So when your browser connects to a web server, it's going to request a page, an HTML page. That HTML page is going to give us some structure. What we want to do is make sure that we separate out the look and feel of our web page from the structure of our web page. And to do that, we have a separate language called CSS, which stands for Cascading Style Sheet. If you haven't seen it before, HTML is hypertext markup language. The CSS dictates what things look like, and we'll show you how those fit together. And then finally, we want to add some interactivity. We want to turn our page into an interactive website or web application. We're going to use ECMA script. And ECMA script is the formal and official name for JavaScript. Brendan Eich invented the language way back when the web first got developed, and he was asked to build a lightweight, single-threaded language that allowed them to add some interactivity to pages. He came up with ECMA script. The marketing folks said ECMA script will never catch on. It's a stupid name. Too acronym-y, too computer science-y. But you know what's really cool right now is Java. And Brendan said, what the hell are you talking about? They're completely unrelated. And the marketing folks said, no, Java. Yeah, that's it. JavaScript. That'll work. And the name stuck. Okay. Java is to JavaScript what a car is to carpet. They're that related. Okay. Not at all. So we're going to start with the HTML5. We're going to build some structure and some framework. We're going to add some CSS. You're going to get frustrated. I'll add some more CSS. Life will get a little easier. We'll start to add JavaScript. You'll wonder, hey, where'd all the HTML stuff go? It's kind of the way it goes. All right. Programming for websites, pages, and apps is all the same to all of us. So when we start programming for the web, recognize that a website, a web page, and a web app are all the same thing. They use the same technology. They're built the exact same way with the exact same structure. The difference is from a user's perspective. A web page typically scrolls up and down vertically and will have a concept of a fold. The part you see on the screen without scrolling is called above the fold, and from the part that you have to scroll to see is called below the fold, and we think of it as a web page. A website is a collection of pages that might be linked together, and a web app all resides in a single page. You never have to scroll horizontally or vertically. There are controls inside the web application that let you see different components there. Historically, this all came from a guy called Tim Berners-Lee, who was working as a researcher in CERN in Switzerland. And I became aware of this because I was working in a company at the time, and somebody was like, "Hey, did you see this new cool tool they put out?" And all it was is text. Now, they were solving a problem. And the problem was they were doing research papers for academia. They'd write the research paper in a markup language. It would get formatted. It would get sent to a printer. They would print off 1,000 copies. They'd send them to a bunch of university libraries. Some librarian, being really diligent, would point out 3 typos. They would have to go back and edit the document, reformat the document, reprint the document, resend the document to all the libraries. And after you do 2 or 3 edits like that, you get really frustrated. So what Tim Berners-Lee and his undergrad team did is they came up with a way of writing markup so they could put it on their central server. And then they created a tool that would load that document from the central server and display it graphically, reformat it as a document. That way, if they made a mistake, they could go back to their central server, edit their one document, and magically, the next time people looked at it, it looked correct. The guy who made the most money out of this was the guy who made the first web servers called Netscape. There's a guy named Horowitz. He's a billionaire now, and he's an investor that goes and seeds money into technology companies. So the way they came up with doing this is they built everything inside HTML, formatting everything. And what they quickly discovered was maintainability was really kind of a problem. So these days we've taken the formatting stuff out of HTML and we've put it in CSS. Now, all of these things are built up out of files, and the files are all clear text. There's nothing encrypted about the web. They're not Word documents, they're not binary, they're not compiled, they're just text files. The server looks at a folder, and it delivers files based on what's requested of it. The browser, and you guys should be using Chrome for this, the browser in the URL bar makes requests for pages. Those pages themselves can make requests for subcomponents or subparts. Okay? As with all programming, we're going to write some source text files. Those text files, we're going to do some work inside the files to make our lives easier. Specifically, the way we capitalize things, the way we punctuate things, and the way we indent things. Don't underestimate the importance of indentation. The way we indent them tells us the structure of the document, and it was derived from a time before we had color-coded syntax highlighting. And the idea is if you looked at one of these text source documents for any programming language in Notepad, you'd still be able to figure out what was going on. So that's the idea. There's a couple other concepts there too, and they'll make more sense later, but just stick them in the back of your head. No method, routine, or subcomponent should be longer than a page or wider than 80 columns. Now, the reason for that comes historically because we used to print things out. The modern logistical reason is that some surveys of programmers storing stuff on GitHub have shown that programmers spend upwards of 70% of their day scrolling through code up and down. Now, if you are having to pay a programmer out of your pocket and you have to pay them $75,000 a year, and 70% of that money goes to watching them scroll, how much value do you think you're getting out of your dollars? Out of your personal money? Would you want to pay $40,000 a year to watch someone scroll? Because if the answer isn't yes, then design your software so you minimize the amount of scrolling you do. Right? Which is why when we build stuff, we build it typically to no more than a page at a time. We might have stuff that gets long. When it gets long, we break it into smaller pieces. Okay. Now, as we build our applications and structure our code, we're going to break it into chunks or blocks. Small things are easier to debug than big things. So we're going to break it into small logical chunks. We're going to use the indentation and whatever block delimiter makes sense for the programming language we're using to indicate which blocks are which. The other thing we're going to do is in our editor, we're going to make sure that when you hit the tab key, it inserts 4 spaces. Not 2 spaces, not 6 spaces, 4 spaces. Why 4 spaces? Well, 4 is big enough that people can see the indentation. And 4 is the most common indentation size on the internet. And we use spaces instead of tabs because the single tab character can be reassigned to different widths. So if you're in Notepad and you say a tab is 8 characters wide, all of a sudden all of your formatting gets reset. So we don't use a tab character, we use 4 individual space characters. Now the good part is all the programming editors do this automatically. When you hit the tab key, it actually puts just 4 independent characters in. Okay. We're going to get into how we break things into individual files, but suffice it to say, the most important part of all of this is spacing, indentation are all considered white space and they're all ignored by compilers and interpreters. They're there for you as a programmer. And the most important thing is be consistent, right? There's nothing that's more difficult to debug than something where the indentation is 3 spaces for 3 lines, 4 spaces for the next 2 lines, 2 spaces for the next line. It's very, very challenging to try and figure out what is going on. So, because that white spacing is ignored, you might as well make it nice and neat inside your files. Okay. Combine the white space, the indentation, and the comments you're going to write in your code, and you should be able to come up with stuff that minimizes scrolling. You describe why you're doing things, and your code is relatively short and straightforward. It will make your life a lot easier to debug. Everybody will ignore all of this in the next 2 weeks. I'm fully aware of that. You will get into that C# course with Hugo, and you will write one routine, and it'll be 650 lines long, and you will write it all at once without ever testing it, and you will push the play button, and it will break horribly, and you'll throw your hands in the air and go, I don't get it, it doesn't work. Right? But part of the reason it doesn't work is because the skills you need to debug these things have to do with making lots of small little pieces that you can easily debug. So try and come back to this stuff. This is true of all programming languages. This isn't specific to the web. Okay. In the web, every document has that similar structure. Every document has an HTML part that gets loaded first. And I'm going to show you what the HTML part looks like. There are very small number of required things. All of the things that get loaded by the browser, if there's an error, it gets ignored. This is an interpreted environment. It reads one line at a time. If it can understand the line, it will try and do something. If it can guess at what the error is, it'll try and fill in the blanks. Sometimes it will guess wrong. If it can't figure it out, it just stops right there. So, for instance, with our HTML, we're going to have tags that delimit blocks. Those tags need an opening part and a closing part. If you forget to put the closing part in, it is possible the browser might figure it out, and things could run just fine. However, you're letting the browser guess at what you intended, and that's not generally conducive to really good applications. So, where do we start with all this? Well, every single web application starts with a core, simple web document, and that document is always called the same thing, index.html. It's not myapp.html, it's not assignment1.html, it's not my site.html, it's index.html. There are no other alternatives. Okay? And the reason for that is that all commercial web servers look for index.html as the root document when you request a URL. Here we are in the browser. This address bar is what we're requesting. Let's go. All right. So when we type something in the address bar, we are making a request to a server called localhost, and we're telling that server that we want to talk to port 8080. Now, this isn't going to make sense till about week 3 when we talk about the operating system stuff, week 4. This tells us how we want to talk to each other. We want to talk hypertext markup. That means I want to send text and I want to receive text. And the unwritten part is that I really want index.html out of that folder. Now, the web server has a root. And that root part is when we run our web server, we get a server name and the root folder that we're running the web server from. In other words, when we go into our www folder, or go to the folder above it, rather, and run live server with Node, what we're really doing is we're starting a web server that can see a www folder underneath its root. Now, this will be more clear when we add that first HTML file. So let's just go do it. Inside that www folder, we created a hello folder. Create an index.html in there.
Inside the hello server? The hello folder?
Yeah. So inside your hello folder, and let me try this.
You want us to call the folder base index.html?
Nope, not the folder. Just call the folder hello. Let's go here. Go to your text channel in Discord. And click on that link.
Continue web or open Visual Studio Code?
Open Visual Studio Code. I got one.
Yeah, I think I joined. I think I joined.
It should just let you join as a guest. It says I have one connection.
I'm in it for sure. I can see all this code that's in there. There's nothing in your hello folder.
There's nothing in my hello folder.
It's on the download folder.
There's the second one. Jim.
David, can you spin my screen to the right? This time is link. Watch the thing.
There's the third.
Can't tell if I'm in it or not. What am I supposed to be seeing?
There we go. Who else? I don't know who the guests are. I just see participant list. And I don't care if you join as a guest. It really doesn't. There's Clover's in. Two more.
Oh, I had to click enter twice. Oops. I should be in?
You're in, Nick.
Yeah, there we go.
Who are we missing? Who's not in?
I'm here. I'm anonymous, but I'm here.
And there we go. Yay. 1, 2, 3. We got one more. So, every one of you should have VS Code up and you should be able to see what I have.
Yes.
So if I go into my hello folder, I'm going to right click there and create a new, no, not a new folder. I'm going to create a new file, index.html. Okay. Every time we build a new web page, web app, website, we start with the folder, and the folder is the same name as the project or the assignment or the application.
So you want us to do this as well at the same time?
Yeah, you can build this on your own side. So you can watch mine, build yours. You'll have 2 copies of VS Code up.
Oh, we get to go to this here tomorrow. Are we not using the command prompt anymore?
Nope, not yet. I'll get to integrating those 2 pieces together. So if you kind of see my screen up here, here's the one on the left I'm sharing, and here's the one on the right you're going to do.
How do you create a new folder? Yeah, file, open folder.
New folder.
Code. File, new file. Open
Yeah.
folder. Open folder. See users. View files. And go to hello, right?
Yeah. Yeah, the quick demo of the, if you watch in Discord, the quick demo of the IDE, they're integrated development environments. That's the idea is you can do everything from the environment. So in Visual Studio Code, the top icon up here.
Okay, then select new file and
Just create new file. Okay.
new file and type those index.html.
Correct.
Change the name.
Okay. So in this environment, we got a bunch of things working for us. The first one is the Explorer is this panel here. Every button down the side will show up in this panel on the left. The top one is the Explorer, which is just looking at the files on your file system. The next one down is Run and Debug. We haven't configured or set it up yet, so just skip over it for right now. Eventually, we'll hook it up. The next one down is Source Control. Again, integrated Git with your editor, so you don't ever have to leave. The next one down says Extensions. So these are all plugins and tools that can make your life easier that third parties, otherwise other developers, have written to make Visual Studio Code work correctly and have some cool extra functionality. I get some crazy syntax coloring here. I get fancy icons, that kind of stuff. I have a huge list of plugins and extensions that I use. You don't need them all. Okay? And as David suggested to me the other day, I think it's probably better that you just stick bare bones for the first week or two until you get a sense of what you're playing with. There's a search function that searches through all files. So you can search for something across multiple files and folders. I have a plugin that does project management. I have a plugin that loads different workspaces. And Visual Studio Code uses a simple workspace methodology. That workspace is a file that identifies a folder or set of folders in a related project. We'll get into playing with those. The Remote Explorer is really tied into the Live Share. I have a note-taking tool. I have the Live Share, which we're all using right now. I have a to-do tool, and I have my Python tools. There we go. So you can see, I can see who's in the Live Share. Okay. Now, typically when I run the Live Share, I'm going to run the Live Share read-only, so you can see what I'm doing. You can cut and paste out of it. Okay. So if it gets really hairy or complicated, or you fall behind a little bit, that's what the Live Share is there for, is you can go and take a look at what we're doing. It's kind of helpful in a lot of cases because when we're writing software, we often write something, kind of get it working, and then go, hey, wait, there's a better way. And then we'll almost always delete it in place and edit it again. So be prepared to see some of that. There's a bunch of other open and close tabs you have here. So open editors should be pretty obvious. The folder that I'm in, the root folder, is right here. So for you guys, this should be www in your local editor. I've got an outline mode, a timeline, some other cool stuff here. I can get into that as we start to add those things. All right, you got a rough idea what's going on? It's really hard because there's no files here.
I accidentally went to my hello folder. Oh, I went to my hello folder. Yeah, I got it. How do you change it? Yeah. Oh, so like open folder.
Yeah.
www. What did you do? To go file, open folder, keyboard.
Yeah. You can create files and folders directly from this environment. You don't have to go to the File Explorer. You don't have to go to the command prompt.
And you create a new folder, and then you call it index.
HTML.
New folder or a new?
A new file.
New file, not folder.
Right? Files all have extensions.
I have this other thing about www folder called package-lock.json.
Yeah, just ignore it. Right? Don't delete it.
Okay.
Just ignore it. It's related to Node and the Node package manager. Okay? So, integrated development environment. If you click on the terminal menu at the top, look in the Live Share, I can create a new terminal, and it drops. And this is exactly the same terminal was created from the CMD prompt.
Oh, wow, it is, yeah.
Okay? So now if I want to install a Node package, I can just type it right here. And it starts it, you notice, in the right folder already. So integrated development, I got my editor, I got my files and folders over here, I've got my terminal down here, and I can run the live server directly from here if I want to. Okay. Cool? It's a lot to take in all at once. Boom. Come on, this is lightweight compared to Visual Studio Community. All right, let's put something in that page. So what does a single page work like? Well, let's start with, and you're seeing this in Discord here, let's start with the structure of a document. Every document starts with that first line, doc type HTML. Every single element in an HTML document starts with a less than sign, a tag name, and then a greater than sign to close it. Doc type HTML is a single entry that tells the browser that loads this file that this is an HTML document. The rest of the stuff in here that I have in red are how we put comments in our HTML file. Okay, so less than, exclamation, dash, dash, and it's closed by dash, dash, greater than. All right. Now the diagram on the right is a fairly accurate view of what's going on inside your browser, which is a pretty amazing piece of software. When you type something in that URL bar, it sends that off to the web server. Which web server? The one that you identified as the name of the server, you know? When you send it off, the default is port 8080, and by convention, all web developers typically set up their servers to listen on port 8080 on the machine that the server is running on, so you don't have to put the 8080 in most of the time. By convention, they also set up their web servers to always, by default, load index.html. So if you don't put index.html in that URL bar, it assumes it's index.html. Okay, that's why we name our main file index.html. Now what happens is that request gets sent off to the server. The server says, oh, you want index.html. It grabs index.html off the local hard drive, sends it through the internet back to your browser, and your browser reads that text file and interprets it. In the black box on the right here is how it interprets it. The text file comes from the internet into our networking core, and we go handle the request. So the request was for a certain HTML page. We're going to take that HTML page. We get a big chunk of text. It's like getting a text document. We're going to parse it. And parse it means we're going to go have the browser is going to do this for us. It's going to go walk through our document, our HTML, and it's going to create a data structure. That data structure is called the document, or the DOM, Document Object Model. And it's also going to peel out the JavaScript and send it off to the JavaScript interpreter. That Document Object Model is going to go to a layout engine inside your browser, and that layout engine is going to render onto the screen. If you change this, the screen changes. The browser does that for us automatically. So when we're building apps and pages, our primary function is going to be, aside from our own data, is whenever we want to make something look different to the user, we change the DOM, and the browser takes care of updating or re-rendering the screen for us.
DOM stands for what?
Document Object Model. Right. Now the JavaScript stuff off to the side here we're going to get to, but as soon as the document object model is built, it gets laid out and rendered, and then the JavaScript runs on the side. Okay. And the JavaScript typically is going to be stuff that will do some work to begin with, and then we'll sit idle waiting for something to happen, waiting for an event to happen. So how do we write this HTML page? Well, let me put my doc type in here. Okay. Remember in elementary school, your teachers always told you to put your name and date on things? This is the way you put your name and date on software. Software is copyrighted as a literary work. It's the same as Harry Potter. It's the same way J.K. Rowling copyrighted Harry Potter. The source code is what gets copyrighted. If you do something brilliant and you don't put your name and date on it this way with a copyright, and I like it, I will put my name and date on it and I will own it.
Did you do something on the screen share?
It's on the live share.
Where? It's an index.html. It's not updating for me. I just see it online. Oh, who did it? Oh, okay, that's let me do this on my own. Doesn't seem to be updating for me. Well, I don't play anything after I type that. You can check the pictures
Yeah.
yeah, I just refresh the page. I'm going back and do this thing right now. Okay, well there you go. Now it's there. Interesting.
All cool? Everyone can see it?
Yeah.
Right. Okay. So what's the first thing? Everything in our page gets wrapped in an HTML tag. Everything. Nothing before that HTML tag gets interpreted. Nothing after gets interpreted. So that's what tells the browser where to start and where to end. Every tag is done the same way. The tags have less than, greater than signs, and the name of the tag. And then they have a slash, less than slash, to end the tag. So in this case, HTML, and we close it. Now I have an auto-completion tool that makes it faster to write. That's one of the plugins I have. Right? Cool. And you can see I've got the indentation going already. Right? So this part's called the tag. Right? And this is an element. So this whole thing we call an element. Elements can be nested. All right? Within that HTML tag, we have two tags that we use, and they're always the same. There's a head tag and a body tag. Okay? Inside the head tag tells the browser all the things additionally to load and all the things that aren't going to be drawn. It's meta information that we might need to draw this page. The body tag is exactly what we're going to see. So we start with a head tag and a body tag. Right? And I would be horribly remiss if we didn't write the traditional hello world in our HTML page. See, it's called hello. And I didn't want to write hello world because, again, I'm lazy and that's a lot of typing. So if we fill this in with hello world, I'm going to create a heading. Now, there are hundreds of tags. I'm not going to walk you through every tag. I'm going to show you the structure about how tags work. I'm going to show you the 6 or 8 main tags that we use all the time. I might expand on that in the future as we go. And then I'm going to point you at the manual. Okay. Now, some of these tags are very, very old. Some of them still work. Some of them are kind of deprecated and we don't use them that much anymore. Typically, the ones that have to do with formatting, we don't use that much. Like this one, we don't use that much. Okay. As we put these pieces together, we can test it out. And here's the way we test it out. The first thing is we go down to the terminal part and just type live server. Now, if the path got set up correctly with Node, this should just find the Node live server. It should just run. So if it tells you the command not found, right? Does anyone get it to say live server not found?
Mine said roaming f100 f slash roaming npm live servers can't be loaded because running scripts disabled on the system. Yeah, mine says that too.
Running script. Right. So let's walk through it. There's a couple different pieces here. The first one is within our environment. Let me bring back this guy. So I'll bring this guy onto Discord. Inside your environment here, you type the command set. It shows you this big mess of stuff. S-E-T. Okay. Big mess of stuff. But if you look at it closely, like this guy, for instance, that's an environment variable called public, and it is set to C users public. There's another environment variable called user profile, set to C users Scott. Yours will be set to, of course, your folder. And we scroll up a little bit, there's a very specific one called the path. Okay. This path is a list of folders that are searched every time you type a command on the command line. So if I type and use the command where to find notepad.exe, it searches the path and finds where notepad.exe is by looking at each folder in the path in sequence. Okay. So when you type a command, if it's not one of the command prompt internal commands, it searches your path for them. Specifically, there's where my Node.js is installed. Okay. Node has its own environment. So these environment variables are how your Windows program finds other programs. It's not just magic. It's not just crazy file extensions, although that's part of it. It uses this path to find things. With your Node environment gets installed into your local folder, right? You installed the user version. So I wonder if it's easier if I do this. Easier if I do this? Let me show the hidden files. Here's all the hidden files in my folder. So the hidden files are all shadowed, right? In particular, there's one called app data. And local. Is it here? Is it remote? Do you remember, David? Yeah, the path to node. Roaming. Yeah, it's roaming. Okay, there we go. Okay, here's where you're going to find it. So bring up the File Explorer. Go to the View menu.
Yeah, I found that. I was app data. Did you go to local?
Roaming.
Roaming, and then you went to
NPM.
NPM. Found that.
Okay. Inside NPM, you want to add this into your path in your environment variable. And the way you do that is on the Start menu, bring up Settings, and search for env, environment. And it'll say Edit Environment Variables for your account.
Yeah.
When it comes up with this little thing, you're going to select the path and click Edit. And then you're going to go Add Users, your username, app data, roaming, NPM to the end of that path.
And just hit OK.
And hit OK. And then hit OK.
It was already loaded there, but it still didn't work.
Right?
I'll try that again.
Now, one thing you should know is that each of these command prompts inherits its environment when it started and never looks at its environment again. Which means once you change the path, these environments don't have that update. You have to close them and restart them. Same with the one inside VS Code. You have to create a new one.
Close VS Code and open it back up.
Not VS Code, just the terminal. Yeah.
Is there a step after we NPM installed live service? I remember there was steps after that. I don't think we start something or we did.
Okay, so let me walk through it again right from the start. Command prompt, npm install live server globally. Okay. It does its thing. Now, and you'll only have to do this once. Go to Settings. Find your environment variables for your account. Go to the path, edit it, add the app data roaming NPM path, right? It's C users, your username, app data roaming NPM. Add it, close that. Then you have to close this terminal and open it again.
David, can you help me again?
And let's just type where live server.
Why do we need to type here again? So, do you want us to close that other command, that order command prompt?
Yeah. Yeah.
Say it again. And you typed in where live dash server. Yeah, it says the same thing as yours.
Cool.
Going forward to be Yeah, I need to change my system language to all English in terms of major user and next practice.
Right. Okay. Has everyone kind of got this far?
Yeah, I'm not your step here.
Okay.
It works in my command console, but not at Visual Studio.
Not in Visual Studio Code. So you may have to stop and restart Visual Studio Code, get it to pick up a new environment.
Yeah, I think I'm going to close Visual Studio Code here.
Yeah.
NV? ENV. Okay, got it. Close. Okay, I'm back in exactly where I was beforehand. Now there's another option, but that says, do you want me to try typing live server again on
In VS Code, yeah.
yeah, live dash server, correct?
Correct.
And this doesn't work. It says cannot be loaded, script is disabled from the system.
Scripts disabled. What? That is new. Show me your screen. Anyone else having issues?
Okay, I'm the answer. Oh, probably this one. So record the column or this one? Oh, the other one, okay.
Okay, close that terminal, Andre.
Thank God. Now what do I do? Panel?
Oh, okay. Hold on. In your VS Code, Andre, on the right-hand side by the terminal, it says it's using PowerShell.
It's using what, sorry?
PowerShell.
Yeah.
So close all of those with the little garbage can icon. Now, under Terminal, go New Terminal. And at the top there, change PowerShell to...
When I click on PowerShell, it just goes...
Yeah, Command Prompt. Now try it.
There it goes. Oh yeah, and then so the website and it says hello. How's that? Interesting. Okay.
Okay, so there's the CMD prompt is not the only command line on your computer. They're called shell programs.
Yeah.
And Microsoft tried to convert everybody over to their PowerShell program.
Yeah.
And other than IT guys, most people don't use it.
I've never even heard of PowerShell before.
Right. But VS Code, being from Microsoft, decided that PowerShell should be the default.
Yeah.
Okay.
That's their own thing.
So there is a setting in VS Code. You can set the command prompt to be the default terminal rather than the PowerShell.
Where does that be?
Under Settings, there's a gear wheel at the bottom left. Yeah. Go to Settings. And then I would just search for it. Terminal. And you're going to have to dig through the terminal settings. I think it says terminal. Okay. Integrated Explorer. But you can see here it says Windows exec customizes which terminal to run on Windows.
First time?
It's in my live share.
We can't see it on the live share. Or maybe your live share is frozen for me again.
If you restarted VS Code, then you'll have to reconnect again.
Yeah, can you
I'll put it on Discord as well.
It says I have to wait for approval on VS Code share.
So settings is down here. And then you click on settings, and then I just search for terminal, and that's the terminal you want.
Second one, where am I formatting? Windows. Okay, I see, and it's a CMD.
Yeah.
Yeah, nice, I saw.
And what's the other setting here? Tell how often I update this. Terminal integrated default profile. Choose command prompt. Way down. Halfway. Looks like it's about halfway. Now I gotta go find it again. Yeah, default profile. Do that.
Default command prompt. Got it.
Okay, that just sets the default. So what you are getting a view behind the scenes of is Visual Studio Community and Visual Studio Code have a bunch of default settings and configurations behind them. Visual Studio Code is lighter weight, gives you more configurability, but there's more things you have to configure yourself out of the box. So it's always a trade-off. You'll find that with every programming environment you have. This is closer to a Python environment where you start with your own editor and you have to configure your own pieces. The C#, C++ world, C# is only Windows. By Microsoft, for Microsoft, only runs on Microsoft. So the Visual Studio Community environment fits that to a T. And so it's preset that everything just works out of the box. Now you can do Visual Studio .NET C# applications in VS Code.
Yeah.
There's a command line install for the .NET Core, and if you've already installed Visual Studio Community, the .NET Core is already there. In other words, you could use this editor and just load up a C# program and write it. Right? But this run debug button on the side here, you would have to configure to run the C# compiler and the C# linker and the debugger. And that's a bit of a pain most people don't want to go through. So for term 1, that's why the guys use Visual Studio Community, is because all of that stuff is pre-configured. Let me throw this up to the side here.
That's so cool.
Okay. So here we go. I got a few things open here. So index.html. Now, has everyone got their live server running?
Yes, I do.
And you can see in the browser the hello world.
Yeah, I have a Chrome website. That's cool.
Okay. Now, the only reason I tell people to use Chrome is because the world uses Chrome.
Oh my, wow.
Okay, so as a developer, we're going to beat the religious wars out of you. Macs are better than PCs. No, I don't care. I'm a developer and I go where the money is. Where's my audience when I'm building web stuff?
Chrome, Windows.
Chrome, Windows. So I build Chrome Windows. And if tomorrow it's Firefox, then I switch gears and I do Firefox.
Quick question.
Yep.
Isn't Opera GX like a less RAM intensive Chrome kind of?
Yes, except it doesn't have all the features that Chrome has. Yeah. It just doesn't have the development budget. I mean, the reality is this is a business, right? So when Opera takes a look at what they're doing and they take their 25 developers and go, okay, what feature are we working on this week? They come up with something cool and new that no one's ever seen before. They're like, wow, that's great. What does Google do? Well, Google has a guy that's watching Chrome all the time and says, hey, yesterday this new feature dropped in Opera. Let's get 1,000 engineers and we'll have it by next week.
Yeah.
Because they have an unlimited budget, right?
Yeah.
So all of a sudden that advantage that Opera had goes away inside days.
Well, apart from their RAM usage.
Right. And Chrome's RAM usage is really just about convenience. More stuff.
Makes it quicker.
Yeah, makes it quicker. And this is a common trade-off in all programming, not just specific to browsers. Stuff you keep in RAM is faster, so you trade performance for space.
Yeah.
There are differences between the browsers. Chrome, Edge, and Safari all use the same layout and rendering engine under the hood. So if it works on Chrome, it will probably also work in Edge and Safari. Firefox's layout engine is its own, and it's weird. It does weird things. I will point out a couple of them as we go, but if something looks great on Chrome, it doesn't necessarily look great in Firefox. So professional web developers often have all of these browsers installed. And they will build it for Chrome because that's where most of the audience is, and then they will test it on the other browsers to make sure it still looks the same way it's supposed to look. And special case for the special browsers. But as you can see by the statistics, I think, Chrome is where you should test things. And for our purposes, you really don't need to test it on all browsers. Okay. All right. You guys keen to keep going? Do you need another break?
Not saying no to a break.
I'm close.
But I can just refresh the page a lot.
Right. So as long as it's just an HTML page, you can refresh it. The live server is nice because it auto refreshes for us.
Yeah.
Every time you touch the code, it refreshes the page.
That's fine. Maybe it's fun. I have NPM. Everything's supposed to be working, but who knows?
All right. All right. It's probably because it's running the PowerShell. Same as Andre's was, because that's the default. I switched it to run the command prompt. We can come back and do that just after lunch. Okay? Okay, it'll take 2 minutes. So structure of a document, everything has this structure to begin with. Every index.html that begins every web page, site, or application has this structure to it. There are no exceptions. It's always the same way. We will add stuff to this, but it will always have this. The one thing that's different is this content in the body is what we're interested in. That's the stuff that we're going to put our page together in. Our content is made up of tags, and tags get used to form elements, and every element has the same components to it. Every tag has a tag name, it has some delimiters around it, and it has some content between the opening and closing tags. Make sure to close every tag. Okay? There are some specific tags that don't need closing, and I'll highlight them when we get to them. The opening and closing tags are going to always be the same name. They're just going to have the little slash in front of them. Now, The whole thing is referred to as an element, and you can nest elements inside elements. Now here's the interesting part, is that while I'm showing you these header tags, there's really only two other tags you need to know other than head, body, and HTML to make an entire HTML page or site. And those tags are the div tag and the span tag. Remember, this stuff all came from documents originally, which means it flows down the page. Divs are blocks. Think of them as squares, one beneath the other. Okay? When we get into styling some things, which we'll do next time, we're going to use the styling information to determine whether the blocks go top to bottom or left to right, top to bottom. Spans are what we call inline. In other words, they go left to right. If the browser's too narrow, they'll wrap. So spans go this way, blocks go this way. Right? Divs are blocks, divisions. Right? So when we build applications, what we typically do is we draw out or lay out the page on paper. And we draw boxes. And as we draw boxes, we recognize that each box is going to get turned into a division. And sometimes we're going to nest these divisions to help us lay things out. What we're then going to do is we're going to add another language element. We're going to add cascading style sheets to add formatting information to those boxes. Okay. So the divs are called block elements. The spans are called inline elements. And there are a few others, but if you have HTML, head, body, div, and span, you have enough to build every web page on the planet. You don't need anything else, technically. Everything else actually just makes it easier for us to read the HTML. Okay. Now, some of the other kinds of tags we see are there to make it semantically easier for us to read, and that is, it's easier to understand what's going on. So both of these things will look exactly the same on your browser. The welcome back built inside a div, followed by another div with some content, looks exactly the same as the one on the right. The one on the right, we identify a header, which has some default styling to it, and we identify a paragraph. The other part is, you see the white space here between to and lately? Right? This right here. Okay. The browser ignores it. So laying out things inside the HTML file is for you, not for the browser. The browser is going to collapse all the white space away. Same with the indentation. The indentation there is for you. So now we can start to build together all the things that we would normally put into a page. And really, we don't need a lot of different tags. I now have a span which runs inline inside of a div. Now, really, I'm only going to do this for illustration purposes. There's additional information we would add to this to add different look and feel to the I am wrapped in something, I think. And as we add those pieces to our individual pages, we're going to have to think about, well, what do I want to look different? Okay. Now, sometimes you're going to need more than just the tag. Sometimes you're going to need things that you want other information attached to. In this case, I've got an anchor tag, and that anchor tag is supposed to take me to Google. But one of the revelations of web pages and web documents is the ability to add additional attributes to any tag. There's a common set of attributes that you can add to every tag. You can always add an ID attribute or a class attribute, and we'll explain what those are for. In this case, the anchor attribute, or the anchor tag, has a specific attribute called hyperlink reference. And that's where you put in the URL if you want to link to something. In this case, this will link to google.ca when you click on the word Google. So try putting that in your page. Now, there's no spaces around the equal sign, and you have to use double quotes.
Why, after I do live server one time, it won't do it again?
You don't need to run it a second time. It's already running. You just leave it running in the background. Yeah.
Even if like you go type some stuff, it'll say it wants it.
That's the whole thing.
Mine's working. Oh, that's pretty cool. I just fixed it. Pretty cool. Go back to Visual Studio and accidentally close all of them. So it doesn't seem to be updating that to me.
So the live update.
Oh, okay. The one that's happening now or after one?
So that's the idea behind that live server. You run it once at the beginning of the session, and it just sits there and monitors the folder. And if anything changes in any file in the folder, it refreshes the browser automatically. So you don't have to keep hitting refresh. So if that's the case, usually what we find is the text you're editing is in a folder different from the one the live server is watching.
Oh, it's in the same HTML thing. Strange. What you can do is in the terminal, like if you're on the terminal, press F1+B, which is stop your live server, and restart it, and then kind of reopen the window and so on. That's another thing that happens with live server. You'll have like the first page that it opened, that's refreshing, and then it'll open another one, and then that one is refreshing. Just take it and like stop it with Ctrl+C, and then it'll change the text from hello world to goodbye world.
Right. So as we build more and more applications, what we're going to see is not only we're going to expand with additional tags.
How long does it take to update?
It's instant. If it's looking at the right folder, it's instant.
How do you say it? Okay, yeah. Save it.
Right. So we're going to add attributes to these tags to get things to happen. So every tag has a few attributes that are common. And the two most common attributes that we add are IDs and classes. We use IDs so that when we start using JavaScript, we can refer to a specific element in our document. We use classes to attach CSS or cascading styles to specific elements in our document. And the classes we'll use by class name. So now we can start to add different components inside our HTML. So if I build a box here,
and you always put this ID inside of the open ones.
yeah, it's always in the opening one. Now, I don't have any special classes called italic or bold. It's not actually going to do anything. So a couple things with these attributes. The first one is the HTML stuff is case insensitive. Uppercase, lowercase, doesn't care. Convention-wise, we write it all in lowercase. So just because I created an ID called my box doesn't mean anything special or different is going to happen. Right? There's nothing that's making it a box. What we want to highlight is that these IDs are things you make up. These IDs should not replicate the kind of tag it is. That's redundant. Don't do it. We know it's a div. It's inside a div.
So what does your website look like right now? Okay.
Yeah. Not going to be crazy. So we got a few minutes. I'm going to show you a few styling things. Now these are style sheets or cascading styles. And we can add the styles with a style attribute. Nothing changed yet, right? Let me turn that off. There. It looks like boring old white. Right? You guys looks pretty close to that.
Exactly the same.
So, let's say I want my box there to have a line around it. I'm going to give it a style and a value.
Did you do that? I'm sure that thing. Oh wait, no, it's right there on that piece. Okay, oh, that's fine.
Yep. There we go.
Yeah.
No, I didn't, but that's okay. I make mistakes all the time. So feel free to point it out.
Okay, yeah, no, there's a box here.
Okay. Let's say I want some additional spacing around it. So let me add another style. So we separate our styles with semicolons.
Mm-hmm.
And I'm going to add some padding. Okay.
Yeah.
Let's say I want to make it dashed. Fat. And red. Okay.
Oh wow, it is cool.
Now, here's a new tag for you. Let's say I don't want to have this style thing go really, really long when I make my span here. So I'm going to create a style tag. Now the style tag goes in the head section. And inside there I can write my styles and attach them to something that lets me search for them. And the way I search for them is by searching for class names. So for instance, I'm going to make the italic. Now the way we describe it is the class name we search for starts with a period and then the name. So it's going to search for italic in the class attribute. Just compress it up a bit here. Every style selector, and I'm going to go over this again next time, but every style selector starts with a curly bracket, ends with a curly bracket.
Just an aside, for some reason my server is updating based on what you're typing. I don't know why that's happening. Yeah. I'm not typing anything, it's just updating with you.
Your browser or your live server?
My live server.
Did you run the live server? Did you run the live server in the live share version of VS Code?
I don't think so. I just opened my own VS Code for a second one and then opened it in the terminal. I mean, it's not really much of a problem, but
No, it's interesting.
just so you know.
All right. So what do we see in here?
For some reason, mine isn't going italic. Yeah, mine hasn't gone italic. Oh, I see why. Never mind.
Typo?
Yeah, it's fine here. Okay, now
Yeah.
it's working.
So this is what I mean. Remember I was talking about this being interpretive? There's no compiler to tell you made a spelling mistake. Two things don't match. Okay? You have to kind of find that stuff yourself. Right? But because it's live instant update, if all of a sudden your browser goes blank, there's something wrong. Right? Now, next time I'm going to show you how the debugger works. Because we do have a debugger. And we'll use that to do some of our styling. Putting styles in the head section is one of the fastest, easiest ways to load them. The way this works is that anything in the style attribute, right, will be applied to the current element. Anything defined in the style section up here identifies what we call classes of styles. So you can put as many styles as you want here. Let's make it blue, and let's make it big. All right. So play with it, have some fun with it. The class attribute identifies some search tags attached to this element. So when the browser goes to render this, what it does is it searches all of the tags and attaches these search terms to this tag. And then it goes through all its styles and goes and searches for all the things that are labeled italic and goes and finds them in the body and applies the styles to them. Right? Now, let's say I want to add some more here. So I don't have to redefine the styles all the time. I'm just going to reuse them. But wait a minute. I don't want this to be italic. I want this to be bold. Now it's bold. All right. I'm going to leave the style sheet stuff for next week. Okay? I'm going to leave you with a cheat sheet. Just turn this on. The cheat sheet is full of HTML tags. The best place other than that to get it is there's a website called W3 Schools. This guy right here. In W3 Schools, you just want the HTML tag reference. Here's all the tags. This is a reference manual. If you don't know how tags work, it's not going to help you. But now that you know how tags and attributes work, you can go look for the footer tag and see how it fits. And feel free to use the try it yourself, because it's an online editor that lets you play with it.
There are even some exercises to do really nice.
Okay? We're going to get you to start designing a biography page for yourselves. That's going to be the first assignment. Keep it simple. I'm not looking for elaborate styling. What I'm looking for is a little bit of content, a couple paragraphs. It's outlined in the assignment.
In Moodle?
It's in Moodle. Okay? And I'm looking for structure. I'm looking for an index.html file with some structure. Now, we didn't get to the Git thing. That's okay. We'll do it next week. Okay? Or maybe, if I'm smart, David will have a tutorial with you where he will get that set up.
It's the T1 Intro to Programming in HTML.
Yeah. You'll also find underneath the resources section a cheat sheet, some exercises to try, and that might be a good place to go with David in a tutorial. And really, it's just like create a new folder and a new index.html all from scratch, all on your own. And just some quick, simple stuff to practice. All right.
Where do we turn this down when we're done?
You don't have the assignment? It's in Moodle. Yeah. Okay.